In this video, we will solve a problem on how we can interface a memory chip with the 8086 microprocessor. So let us take a problem. So our problem is we have to design an interface between the 8086 microprocessor and two chips of 16K into 8 EPROM and two chips of 32K into 8 RAM. So there are two chips for ROM and two chips for RAM. Their sizes are given 16K into 8 and 32K into 8. And we have to select the starting address of the EPROM suitably. The RAM address, it must start at 00000H. So let us try to solve this problem. So in the question we are having two chips for the ROM and two chips for the RAM. Their sizes are 16K into 8 and two RAM chips whose sizes are 32K into 8. So 16K, so total will be 32K and 32K, so total we will have 64K. So 32K is for the ROM and 64K is for the RAM. So this is the total memory capacity, memory size given to us. Now using this memory size, we can determine the number of address lines required to address the ROM and the RAM chips. So for ROM we are having 32 kilobytes of memory. So we will have use the formula 2 raised to the power n equals to capital N. Capital N, it is the number of memory locations or the size of the memory, and small n, it is the number of address lines. So we have to determine it for the 32 kilobytes of memory. So if we calculate this, we will get the value of the address lines as 15. So 15 address lines will be required to address the EPROM. And in the next case, we are having 2 raised to the power n equals to 64 kilobytes. So when we calculate this, we will get the value of n as 16. So 16 address lines will be required to address the RAM chips. So we were having two ROM chips of 32 kilobytes. So we require 15 address lines for them and 32 kilobytes, that is total 64 kilobytes of RAM. So we will require 16 address lines for it. Now we know that we have to interface it with the 8086 microprocessor. So 8086 microprocessor, it is having 20 address lines. From A0 to A19. So out of these 20 address lines, 15 will be used for ROM, that is A0 to A14, and 16 will be used for RAM, that is for A0 to A15. So remaining address lines, in the case of the ROM, we will have A15 to A19. They will be used to form the chip select signal, and in the case of RAM, the remaining are A16 to A19, so they will be used to form the chip select signal. Okay. Now we have calculated the address lines. We know that which lines are used to address these memory chips. So let us see that what are the addresses or the address range of the ROM and the RAM memory chips. 20 address lines are available to us. So let's write the 20 address lines here. So these are the 20 address lines. Now if we study for the EPROM, so for EPROM we require 15 address lines from A0 to A14. So we are going to use these address lines A0 to A14 for the addresses. These address lines, they can take value from 000 to 111. Any value they can take. So one value will be when all the 15 address lines are 0, and one value will be when all the 15 address lines, they will have 1. Okay, so we can have these different values. Now A15 to A19. We can keep these values, any addresses we can use 00 also, and we can use 1 also. We can keep all these 5 address lines at 1 logic also and at 0 logic also. But in the question we are given that we have to choose the EPROM address, starting address suitably when the RAM address should start from 000. So if we put here, if we keep the logic of all these 5 address lines as 0, the starting address for the EPROM will become 00000, but we have to use it for the RAM. So here we have to keep the values of all these address lines as 1, because the starting address 00 is for the RAM. So here we will keep the logic of all these lines as 1. So these are the address range. Starting address will be this and end address will be this. So this will be the start and this is the last address of the EPROM. Starting address, if we calculate 1111, then 100, 000, then again this and this. So the address will come out to be, so if we see, this address will be F8000. So this address will be the starting address. So starting address will be F8000H. Okay. Now ending address, we are having 1111. So FFFF will be the last address. So F, 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 F and F, H. So this is the address range of the EPROM. Now similarly we will calculate for the RAM also. Now for RAM we will require the 16 address lines. So A0 to A15 will be used. So we are going to use A0 to A15 and A16 to A19 will be used to form the chip select signal. So A0 to A15, they can take any value from 00 to 11. So we can have here any value can be in between from this first combination to the last combination. Now starting address for the RAM, we have to choose that it should be 00000. It is given to us in the question. So here we will keep the logic of these 4 address lines as 00. Constant logic will be there. Okay, so if we calculate the address, starting address will be 00000 and end address will be 0FFF. So this is the address range for the RAM and this is the address range for the EPROM. Let us write it here. For EPROM, we are getting the address range. Starting address is F8000H to FFFFH. And for RAM, we are getting 00000H to 0FFFH. So address range for the ROM and RAM we have got. Now we have to interface the 4 chips to the microprocessor. Now we have to, because in the case of ROM we are left with the address lines A16 to A19. So they will be used to form the chip select signal. And in the case of RAM we are left with A16 to A19. Here A15 is also there, so A16 to A19 will be used to form the chip select signal. So let's write it here. For EPROM we are having A15 to A19 and in the case of RAM we are having A16 to A19. Now if we see here the address map, we will see that this address map is not continuous. RAM is located somewhere and ROM is located somewhere in the address map. They are not continuous. Okay, so because here the address map is not continuous, so for forming the chip select signal we will not use the decoder. We will use simple logic gates and those logic gates will form the chip select signal. So A15 to A19 they are kept at logic 1, constant logic 1. So we will give these A15 to A19 as an input to a NAND gate. A15 to A19. And this will form the chip select signal for the ROM, EPROM. Okay, EPROM we have to use A15 to A19. This will form the chip select signal for the EPROM. And A16 to A19, because these lines they are kept at logic 0, so we will here use as negative NAND gate will be used. Negative NAND gate means the 0 input will be converted into 1 here. Inputs will be A16 to A19 and it will form the chip select signal for the RAM. Here logic gates are used, NAND gate and negative NAND gate, okay, to form the chip select signal. So one is our address lines. Also for the chip select signal we will use the bus high enable BHE and the A0 address line of the 8086 microprocessor. Now combination we have to use, one combination will be BHE and the chip select signal, another combination will be A0 and the chip select signal. Now when we have studied about the interfacing, we know that the first step is we have to arrange these memory chips so that we will get the complete 16-bit data. These memory chips they are divided into odd address bank, odd memory address bank and even address memory bank. Okay, so let's draw the interfacing circuit here. These are the 4 memory chips. The ROM are of the size 16K into 8. And RAMs are of the size 32K into 8. One RAM will be for the odd and one will be for the even. For odd we will use because we have the 16-bit data lines D0 to D15, so 88 bits are divided. So here we will use the data bus higher order D8 to D15 for the odd address, and for even address we will use the lower order data bus. So complete 16-bit data can be available to us. Okay, we will combine D0 to D15, so 16-bit data will be there. Now for every chip we will have a chip select signal. This is chip select signal 1, chip select signal 2, this is chip select signal 3, and this is chip select signal 4. Okay. Also ROM, this is read only memory, so only read operation can be performed. So here we are having an output enable signal for the ROM, and for RAM we are having read and write signals. So this read and write will be connected to the read and write memory signals of the microprocessor. So for 8086 we have MEM WR for the write and MEM RD for the read. Here for read we will have MEM RD and MEM WR for the write. For the ROM we will connect only the read signal MEM RD. Here also we will have MEM RD. Here we are using the address lines. For RAM we were using the 16 address lines, and for this we are using the 15 address lines. So A0 to A14 and here A0 to A15. Now how these chip select signals are formed, let's see. We have used the address lines already here. Address lines are connected to the NAND gate and the negative NAND gate. This is for the ROM and this is for RAM. Okay. Now these chip select signals plus the BHE and A0, they will be used to form these 4 chip select signals. Let's see how we can use them. These are the 4 chip select signal. These 2 chip select signal CS1 and CS2, they are for the ROM. Okay. So for ROM we were having one of the chip select signal as C. So here we will connect the C. Okay. Now for CS3 and CS4, these are for RAM, and for RAM we have one of the chip select signal as C dash. So we will connect C dash as one of the input to this NAND gate. Now we have to use the bus high enable and A0 also. So for odd address, in this you can see here, we are having odd and even. So we have to differentiate between these two. We will use BHE and A0 to differentiate it. Now when this signal is 0, this signal is also 0, because this chip select signal, it is coming from the A15 to A19 lines, and A15 to A19 lines, in the address range we have studied that A15 to A19 they are at 1-1 logic. Okay, so the input to these lines here, input is all 1-1, This is a NAND gate, so the output will be 0. Okay, so this 0 output will be provided here in this NAND gate, negative NAND gate. So negative NAND gate, it is going to, because here we are having bubble, so we are going to invert it. So the input will be 1 here. Bus high enable, this is also an active low signal, so it will be 0, it will be inverted. 1 1, so output will be 0. Okay, here also this A0 signal, when BHE is there, then odd ROM will be selected. When A0 is there, then even ROM is selected. Again this will be 1 here and this will be 1, output will be 0, this even ROM chip will be selected. Again here this is 0, this will be inverted, 1 1, output will be 0, and here even RAM will be selected. Here odd RAM will be selected. So in this way the 4 memory chips, ROM and RAM, they are selected. Their chip select signals are formed using the address lines also, and using the bus high enable and the A0 address lines also. So for chip select 1, odd RAM will be selected. Chip select 2, the even ROM will be selected. For CS4, even RAM, and for CS3, odd RAM will be selected. So this is the interfacing circuit in which 4 RAMs, 4 memory chips of different sizes, they are interfaced with the microprocessor. We have used the 20 address lines of the microprocessor also, 16 data lines, and the memory read and write signals also. These are for the 8086 microprocessor. For forming the chip select signals, we have used the NAND gate and the negative NAND gate. Logic gates are used. We have not used decoder here because the address map is discontinuous. In the address map we obtained, because it was not in continuous notation, that is why we have used here the logic gates. Okay, for the address lines we have used separate NAND gates and negative NAND gate, and after this, to form the chip select signal also, we have used the logic gates. So in this problem we have interfaced the memory chips of the sizes 16K into 8 and 32K into 8 with the 8086 microprocessor. So in this way you can solve problems which are based on how to interface the memory chips whose sizes are given in the question with the 8086 microprocessor. So I hope that this problem is clear to you. Thank you.